Section 1.6, geometric sequences. Our objectives are to recognize a geometric sequence, find a common ratio, write a geometric sequence recursively and explicitly, and find the partial sums of a geometric sequence. A geometric sequence is a sequence in which the terms are found by multiplying a preceding term by a non-zero constant. The constant r is called the common ratio of the geometric sequence. So the following sequences are geometric, so we're going to show that they are. For these geometric sequences, in order to make sure they're geometric, you have to have a common ratio. So you take the next term, which would be in this case 3, and divide it by the preceding term. And that has to be equal to 9 divided by 3, which has to be equal to 27 divided by 9, which also has to be equal to 81 over 27. If it doesn't work in one place, then it wouldn't be a geometric sequence. So in this case, our geometric sequence, the common ratio, r value would be 3. So yes, it's a geometric sequence, and r equals 3. So over here, we would do the same thing. So just to show that this is a geometric sequence, negative 32 over 64 has to be equal to 16 over negative 32, which has to be equal to negative 8 over 16, which has to be equal to 4 over negative 8. And when you simplify all these, you get negative 1/2. So yes, this is a geometric sequence, and our common ratio is equal to negative 1/2. So let's go ahead and down a little bit and look at the formulas that we have. So for this, a recursive formula for a geometric sequence is what we're going to look at next. So for the recursive formula, just like arithmetic sequences, in order to write a recursive formula, you have your two different parts. First, you have to state what the first term is, and then a formula for finding the nth term. So in this case, now the formula is, if it's geometric sequence, now our common ratio, we're multiplying it by our previous term. So r times the previous term, where if we're starting off with an n value of 1, then the formula would work for n values greater than or equal to 2. So this would be my recursive formula. For an explicit formula, I don't need to know the previous term, but to get to the nth term, I have to know the first term times that by your common ratio to the n minus 1 power, because whatever term we're on, we need to figure out how many times we've multiplied our common ratio by that then. And this would be for values of n greater than or equal to 1, because if our first term is u sub 1, I should be able to plug 1 into my equation for n and figure out that I end up with my first term. So this would be the explicit form. So those are the two forms that you need to have memorized. So let's go back here. Are the following sequences geometric? If so, what's the common ratio? Write each sequence as a recursive function, and we're going to do also explicit. So just like the last problems, the first thing we want to do is look at these and figure out the common ratio and if it's the same. So 9 divided by 3 has to be equal to 27 divided by 9, and so on. So we just kind of showed this in the last one, which we know this is equal to a value of 3. So I know this is a geometric sequence, and the common ratio is equal to 3. So then my explicit, or let's do recursive, so my recursive form, we would take our first term, which in this case is equal to 3, and a formula for getting the nth term. So u sub n is equal to my common ratio, which is 3, times the previous term, and then this is for n values greater than or equal to 2 for this formula. So that would be my recursive form. And remember, for recursive form, in order to find like the 20th term, I would have to find all the preceding terms up to that value in order to find it. Explicit form, you don't have to do that. So the formula for the nth term for explicit would be equal to my first term, which is 3, times my ratio, which is r, so in this case is 3 as well, to the n minus 1 power for values of n greater than or equal to 1. So notice that it's not greater than or equal to 2, it's 1. So this is my formula. And remember, this is your first term, and this was our common ratio r. And remember, the explicit's nice because I should be able to plug any value in for n, and that gives me the term of the sequence that I want. So I can check my work pretty easily. If I do u sub 1, I should get 3 back. So 3 times 3 to the 1 minus 1 power means I have 3 times 3 to the 0 power. Anything to the 0 power is 1. So u sub 1 is equal to 3, which checks out for my work. So let's go ahead and do the next problem. So for the next one, I want to find if this is going to be a geometric sequence. So I need to show that my common ratio is the same for everything if it is. So that means that 5/4 divided by 5/2 would have to be equal to 5/8 divided by 5/4, which has to be equal to 5/16 divided by 5/8. And so remember, when you're dividing two fractions, multiply by the reciprocal. If you need to use your calculator, that's fine, but you end up figuring out that each of these would be equal to 1/2. So yes, this is a geometric sequence. My common ratio is equal to positive 1/2. So 5/2 times a half gives you 4/2, and times another half gives you 5/8, times another half gives you 5/16. So to write the formulas for this, we have recursive. So the recursive form would be my first term, which is 5/2, and then a formula for the nth term would be equal to my common ratio, which is 1/2, times my previous term for values of n greater than or equal to 2. So then explicit form, so for this one, the formula would be to find the nth term. I'm going to take my first term, which is 5/2, times my common ratio, 1/2, to the n minus 1 power times for n value greater than or equal to 1, because that's what my first term starts off with. So this would be my formula for explicit. So now let's look at another example. So for this next example, it says, write the explicit, or find the common ratio of the geometric sequence with u sub 1 being equal to 2 and u sub 2 equals 8. And we want to list the first 5 terms of the sequence and write the sequence in recursive as a recursive function. So the first thing I would do is I would start off, I'm giving the first 2 terms. So I have 2 and 8, and I don't know anything else yet. So for this, I need to figure out with those 2 things, I can find my common ratio. And in this problem, it has to tell you that it's a geometric sequence, because if you don't know, if it doesn't say that this is a geometric sequence, you could make up a arithmetic sequence for it. So it would have to state whether or not it's geometric or arithmetic. So for this, my common ratio is equal to 8 divided by 2, which would be 4. So that helps me figure out what my other terms are going to be. So it means I'm multiplying 4 by my preceding term. So 2 times 4 is 8. 8 times 4 would be 32. 32 times 4 is 128. 128 times 4 is 512. And so on. So that gives me the first 5 terms of the sequence written out. Then we want to write this as a recursive function, and we're going to do explicit as well. So for recursive form, I state my first term, which is 2, and then the formula to get to the nth term would be equal to my common ratio, which is 4, times my previous term for values of n greater than or equal to 2. And if I wanted to write the explicit, so the explicit form would be to find the nth term, you take your first term, which is 2, multiply it by your common ratio to the n minus 1 times for values of n greater than or equal to 1. So we already talked about the geometric sequence, so I'm going to skip over that. So write the explicit form of a geometric sequence where the first 2 terms are 2 and -2/5, and find the first 5 terms of the sequence. So for this one, we know right now that we have 2 and negative 2/5. And it's told us that, again, it's a geometric sequence. So first things first, I have to find my common ratio. So negative 2/5, I'm dividing that by 2. So that's the same thing as negative 2/5, and this is over 1. So times 1/2, which would be equal to negative 1/5. So that's my common ratio. So then for this, that means each time I'm taking the preceding term and multiplying it by negative 1/5. So 2 times negative 5 gives me negative 2/5. Negative 2/5 times negative 1/5 gives me 2 over 25. So 2 over 25 times negative 5 would give me negative 1 over 125. And then times another negative 1/5 would give me oops, that's negative 2, not 1. So 2 over 625. So now I have the first 5 terms of the sequence, and I can write my formulas. So recursive form, the first term is equal to 2. The formula for the nth term is equal to my common ratio, negative 1/5 times the previous term. That's how we found each term in the sequence for values of n greater than or equal to 2. So that's how I found the terms. And then an explicit form. So explicit form would be the formula for the nth term is equal to my first term, which is 2, times my common ratio to the n minus 1 for values of n greater than or equal to 1. Now we're going to give an example where we're not given our first term. So the fourth and the ninth terms of a geometric sequence are 20 and negative 640. Find the explicit form of the sequence. So in this case, we're given the fourth term is equal to 20, and we know that the ninth term is equal to negative 640. So that means we need to figure out what the first term is, and we also need to figure out what the common ratio is. So let's go ahead and figure out the common ratio. So just like an arithmetic sequence, if this was an arithmetic sequence, we subtract the difference. Now instead of subtracting the difference, we are going to divide the difference. So for this that we have, when we do our formulas, remember that the formula for explicit, to get to the nth term, you take your first term to the r all to the n minus 1 power. So we're going to use that to help us figure out how to find this. So for example, if I wanted to do u sub 4, u sub 4 would be equal to my first term, which we don't know, to the r, which we don't know, n minus 1 power, so this would be 4 minus 1. So the fourth term we know is equal to 20. So 20 equals my first term times r to the third power. So let's do the same thing for the ninth term. So u sub 9 would be equal to my first term times r to the n minus 1 power. So the ninth term we already know is equal to negative 640 equals my first term, and we don't know r, so r to the, in this case we have now 9 minus 1, which would be 8. So arithmetic, you subtract the difference, but now we are going to divide the difference for my common ratio. So my ratio is going to be equal to, you're going to take, in this case, actually I shouldn't write that, let's do it like this. So you take your term that's the farthest one, so the ninth term, so you have negative 640 equals u sub 1 times r to the 8th power, and you're going to divide each of that by my other term, which was 20, u sub 1 r to the 3rd power. Notice when you do that, your first terms cancel out, and you're left with negative 640 over 20 is equal to r to the 8th over r to the 3rd. So we can simplify this using our properties of exponents and just dividing. So negative 640 divided by 20 is negative 32 equals r to the 8th over r to the 3rd. Subtract the exponents and you get r to the 5th. And then take the 5th root. So r is equal to the 5th root of negative 32. And that means r is equal to negative 2. So really, if you notice that it's always the exponent's going to be 1 less than, so you subtract the numbers, or you can just subtract really 9 minus 4, which gives you 5 as well, and then you divide the two numbers. So now that we have our common ratio, I can figure out what my first term is by doing a couple of different things. Since I know the fourth term is 20 and I'm multiplying each term by -2, I could, to figure out the first term, divide by -2 3 times in order to figure out what the first term would be. Or I can use this formula that we used in the actual equation. So if I use this formula, I get 20 is equal to my first term times, now we know our common ratio is -2 to the third power. So when I do this, -2 to the third power gives me -8. So I have 20 equals my first term times -8. So my first term would be equal to 20 divided by -8, which is really equal to -5/2. So I have my first term, and I have my common ratio, so now I can write my two formulas that we have. So my recursive formula would be my first term, which is -5/2, and the formula for the nth term would be equal to my common ratio, so -2 times my previous term for values of n greater than or equal to 2, and my explicit form would be the formula for the nth term is equal to my first term, which is -5/2, times my common ratio to the n minus 1 power for values of n greater than or equal to 1. And so that would be that formula. So let's do another practice of one of these because these can be a little bit harder. All right, so the third and sixth terms of the sequence are 80 and -5120. Find the explicit form of the sequence. So just like the last one, we have to find our first term and our common ratio. So if we know the third term is equal to 80 and the sixth term is equal to -5120. So my common ratio, I know the difference between 6 and 3 is 2, so r to the second power is equal to -5120 divided by 80. So it's a lot easier to do that than the work that we did for the last one. That's all you're really doing. So then for this, I would have to take the square root of both sides. Or sorry, that should be 3, not 2. The cube root of both sides. So r to the third equals this. So then that means r would be equal to the cube root of this, which is -64. So r is equal to -4. So now that I have that, I can find my first term. So I can find my first term by dividing 80 by -4 twice, and that would give me my first term. So just to show you the next way, if I did 80 divided by -4, I get -20. And since I divide it by once, I know this is my second term, so divided by -4 again, and that gives me my first term. So I know my first term is going to be 5. Or you can use your formula in order to figure it out. So I know my formula is u sub n equals my first term times my common ratio to the n minus 1 power. So in this case, I'm going to use my third term. So 80 is equal to my first term, which we're solving for, times my common ratio -4 to the, we're doing the third term, so 3 minus 1 power. So 80 is equal to my first term times -4 to the second power, and -4 squared is really equal to 16. So 80 equals my first term times 16, and so when you divide 80 by 16, you end up with a value of 5. So another way of getting it. So you can do either of the two ways, whichever one you feel more comfortable with. So now I can write my two equations. So explicit, let's do that one first this time. So the explicit form, my nth term would be equal to my first term, which is 5, times -4 to the n minus 1 for values of n greater than or equal to 1. And recursive form, my first term is equal to 5. The n term would be equal to my ratio, which is -4, times u to the n minus 1 for values of n greater or equal to 2. And if I wanted to find the 20th term, I would use my explicit form to do that and plug it in. So next part we have our partial sums of a geometric sequence. The kth partial sum of geometric sequence u sub n with a common ratio r not equal to 1 or 0 is given by this formula. So remember we talked about this is your sigma notation, which means you're finding the sum of all the terms. This is where you start, and this is the ending value, and this is the formula that tells us what to do. So we also said before that when we're finding the kth partial sum, that it's not really necessary you memorize this formula, because remember we can plug this into our calculator. So this is the same thing if we did in our calculator as the sum of the sequence of the formula, comma the variable, comma the starting value, comma the ending value. And we showed that the other day with the arithmetic sequences. So let's do an example. A ball is dropped from a height of 10 feet. It hits the floor and bounces to a height of 7.5 feet. It continues to bounce up and down. On each bounce, it rises to 3/4 the height of the previous bounce. How far has it traveled both up and down when it hits the floor for the 9th time? So now this is the key. We're trying to figure out how far it has traveled. So we're not figuring out how high the bounce is going up. So we have to figure out when it goes up and down what that distance is. We also know that it starts from a height of 10 feet. And we know that our ratio is 3/4 because that's how far we're rising up. So for this, I know that the ratio in this case right now is 3/4, and we're trying to find the distance traveled. So the first thing we want to do is consider how far the ball travels on each bounce. So I like to do a picture in order to help me do this. I know I start with 10 feet and I'm falling. So this is 10, we go down. So then my ball hits the ground and it bounces up, and then it hits the ground again and bounces up, and it's going to keep on going until it eventually will stop. So I want to find the sum of the distance from my first bounce all the way to the 9th time it's going to hit the floor. So this would be the first time it hits the floor, 2nd, 3rd, 4th, 5th, 6th, and this would be 7, so I would need 2 more for the 9th. Now, if this falls down 10, well, it's going to go up 3/4 at height. So 10 times 3/4 would be 7.5. And times another 3/4 would be 5.625, etc. So we want to find the distance traveled. So that means I need to figure out how far up and down I have gone in that first bounce. So 7.5 plus 7.5 is equal to 15. So this is the first bounce that we have traveled. The second bounce, I'm taking this number and multiplying it by 2, and I get 11.25. So this would be the next distance I've traveled. So this is different than the other problems that we did before because of the fact we're doing the distance travel and not the height of the ball on the specific bounce. So for this one, I know that my first term, or my first bounce, the total distance traveled is 15. Now, for that, we can come up with a formula for the nth bounce because we know that the ratio would be equal to 3/4. Now, notice in this time, I didn't start with u sub 0 equals 10. And again, the reason I didn't do that is because I'm not finding the height of the bounce, I'm finding the distance traveled. So we'll have to take that into account later. So for the first bounce, I travel a distance of 15. and we're going to 3/4 that height. So to find a formula for this, U sub n would be equal to 15 times 3/4 to the n minus 1. Of course, n has to be greater than or equal to 1. Now, for this, notice that this doesn't include the first fall of 10 feet. So we're going to have to add that in later. So basically what I'm trying to do is I'm trying to find the sum from the first bounce, n equals 1, to the when it hits the floor for the 9th time. So if it hits the floor for the 9th time, this would be the first time it hits the floor, 2, so this is bounce 1, this would be bounce 2, this is bounce 3, this is bounce 4, 5, 6, and we have 2 more bounces before it hits the floor for the 9th time, so actually it's going to 8 and not to 9. So for the sum from the first bounce all the way to the 8th time it bounces for the function, and of course we have to add the height that we're falling of 10 feet. So this is what we're solving. So if we use the formula that we had up above right here, this formula, we can find what that total is going to be. So it's going to be equal to 10 plus, and then the formula. So the formula states that it's the first term, which is 15, times 1 minus the ratio, which is 3/4 or 0.75, to the k power, and k in this case is 8, over 1 minus 0.75, because that's my r value. So if I do all of this and plug it into my calculator, you would see that you get a value of 63.99 feet. Now remember, we don't have to do this using that formula. I never memorize that formula. I just like to plug it into my calculator. So if I plug it into my calculator, I'm going to do the sum of the sequence of the formula that I found, and you always use the explicit form when you're doing these. So 15 times 0.75 to the n minus 1 power, comma, the variable n, comma, the starting value, which is 1, all the way to 8, and then you'd have to add 10 to that. So if you do this in the calculator, you end up with 63.99 feet. So bring this with you to class, and we'll do some more examples then.